Alright, 1.6 Trig functions. Find the length of an arc subtended on a circle of radius 3 by a central angle of measure 2 pi over 3. Alright, I'm going to draw something here. Alright, if this is the unit circle has a radius of 1. Alright, and let's imagine that this angle cuts a piece of that unit circle, and this is the angle of that's being cut out. This is the subtended arc of the circle of a certain radius. In this case, we have a radius of 3. So this is what we're trying to find. We're trying to find the length of this piece of the circle, given this angle and a certain radius. We want to use this equation. S equals r theta. R is the radius, theta is the central angle measure. So S equals 3 times 2 pi over 3. The 3's cancel out. The subtended arc is 2 pi.
My 50-50 chance of getting the location right down to 100% chance.
Alright, you guys go ahead and try this one, and when you think you have it, hit play. Alright, this is the answer you guys should have gotten. Periodic function, period. I'll go ahead and write this definition down. A function f of x is periodic if there is a positive number p such that f of x plus p equals f of x for every value of x. Basically, the function repeats itself every so often. The smallest such value of p is the period of f. Okay, so however long it takes for a function to repeat itself, that's considered the period. Okay, show that cosine is an even function and sine is odd. If you guys remember the graphs of sine and cosine, the graph of cosine looks something like this. I'm only going to draw one period. Yeah, imagine that's symmetrical, something like that. Notice how it's symmetrical about the y-axis. That makes it an even function. And of course this goes like that because it's periodic. Sine looks very similar. It goes like this. And then it just keeps going like that, kind of in waves, and this is supposed to hit 0, 0. Notice how it's symmetric about the origin. That makes it odd. Okay, you could prove this algebraically also, but I think it's easier to do it graphically. Alright, determine if secant is even or odd. Best way to do this is to graph secant. Oh, you know what? This is a you try. You guys go ahead and try this one, and then hit play when you think you have it. Alright, this is what you guys should have gotten. I drew the graph of cosine because secant is the reciprocal of cosine. And I just used it as a guide to graph secant. Secant is symmetric across the y-axis, so it is even. Alright, example 3. Find all trig values of theta if sine of theta equals negative 3 over 5 and tangent of theta is greater than 0. Okay. I'm going to draw a little picture here. Okay, I drew my unit circle. I didn't label it because that would take too long. Sine of theta is negative 3 over 5. Negative 3 is the opposite side of a triangle, and 5 is the hypotenuse of a triangle. Okay, so the hypotenuse is positive, but the opposite side is negative, so we're going to be going down a ways. So let's do it this way. This is my hypotenuse. We know that it's 5. If this is my theta, this is the opposite side, and we know this is 3. In this case, because I'm going down, it's negative 3. Okay? And this, that would make this positive 4 because we have a 3, 4, 5 triangle. If you can't see that, you can always use the Pythagorean theorem to find the last side. Once we have all 3 sides of the triangle, we can solve for all the trig functions. So, sine of theta we already know is negative 3 over 5. Cosine of theta, 4 over 5. Tangent of theta, negative 3. Let me erase this, start over. Looks too messy. Sine of theta, negative 3 over 5.
Everything else on my computer is fine.
Cosine of theta,
So,
4 over 5. Tangent of theta, negative 3 over 4. And then cosecant, secant, and cotangent are just the reciprocals.
whenever I play Mass Effect 3 of multi,
Cosecant is
it drops
negative 5 over 3.
instantly.
Secant is 5 over 4. Cotangent is negative 4 over 3. Doesn't really matter where the negative is. You might have thought at the beginning why we couldn't go this way instead of this way. And the reason is because tangent of theta has to be less than 0. If we go up this way, tangent of theta is going to be positive 3 over 4 instead of negative 3 over 4. And it needs to be negative. Okay, so at the end, if you end up with something that doesn't work with what you're given, go the other direction, and you should be fine. Alright, go ahead and try this one. Alright, this is the answer you guys should have gotten. Feel free to pause if you need to look at it a little bit. Alright, determine A, the period, B, the domain, C, the range, and D, draw the graph of this function. Okay. Alright, personally, the way I like to do these problems, I like to graph them first and then determine all these things. But I know a lot of textbooks teach it the other way around. If you can get your trig function in this form, then you can find all of these things. If you can get it in this form, your amplitude, they don't really ask for amplitude in this particular problem, but if you're asked that in another problem, your amplitude is going to be the absolute value of A. Your period is going to be the absolute value of B. C is your horizontal shift. And then D is your vertical shift. And once again, these are all absolute value. Okay, so I'm going to do it this way this time. So let me change colors. Let me use a color I haven't used yet. How about that one? I want to get this into this form. So I start with y equals 3. Oh, by the way, I used sine here, but you can actually use sine or cosine. Either one is fine. Any sinusoidal function. Okay. So 3 cosine. I have 2 times x minus pi over 2. What I did here, in order to pull out the 2 and apply it to everything inside the parentheses, if you distribute the 2, you're going to end up with, or 2 times pi over 2 is pi, which is what we had initially. There we go. So, A, the period, is your B, which if 2 pi over B equals 2, multiply both sides by B. Two pi equals 2b. B equals pi. So the period is pi. Domain and range. The domain, you guys all should know that cosine looks like a wave. The domain goes on and on in both directions. Oop. And the range goes from -1 to 1. C? Oh, I guess that's B and C. Now let's graph it. We know that the basic cosine graph looks like this, okay? But in this case, the period is only half that, so it's only going to go to pi. It is, the horizontal shift is pi over 2, and it goes up 1. Okay, so let me label all these. Okay, and it's going to go kind of like this. I'm going to pause here because I know it's going to take me like 5 tries to draw the wave correctly. Alright, after like 5 tries, I've decided this is good enough. I forgot when I was graphing that I need to multiply it by this 3. So it's not going to bounce between, it's not going to have an amplitude of 1, it's going to have an amplitude of 3. So it's going to go 3 above this line. And, yeah. Oh, you know what? This should be going down to 2. 1, 2, 3 below that line. So imagine this is negative 2. Alright. You guys go ahead and try this one. Your graph does not have to be beautiful. It just has to be accurate. You know what? I totally made a mistake here. This is why I always I like to graph it before I start naming stuff. Obviously, the range does not go from negative 1 to 1. It goes from negative 2 to, let's see here, to 4. My bad. There you go. There's the domain of range. Okay, now you can try this one. Alright, so this is what you should have gotten. This obviously continues like this. This continues like that. One important thing to note. Over here, when we found the period, we divided 2 pi over b. But tangent normally only has a period of pi. So instead of 2 pi, you're going to use regular pi. That's a really important difference for you guys to remember. For sine and cosine, those have a normal period of 2 pi. But for tangent, cotangent, those have a period of pi. Okay? So, these are the answers you guys should have gotten. You can take a look. Alright. So sorry, scratch that. My domain and range were like way off. Here's my domain and range. Okay? I apologize if you wrote down the other one. Just go ahead and cross that out. Alright. Oh, look at all that other space. I guess I could have taken up more space. Alright, example 5. This particular example was supposed to come with a table, and I completely forgot to scan this table in there. It says, consider the tuning fork data in the table below that's not there. Find a sinusoidal regression equation, general sine curve, for the data, and superimpose its graph on the scatter plot of the data. Okay, so in this case, the table that's not here, what you would do is you would plug it into your calculator the same way we did those the other 2 tables, and then make a scatter plot. And then you would go to do the whole thing and figure out the best fit equation. In this case, you would use a sine equation for that model. I'm just going to skip that step since the table is not here, and I'll tell you what the equation would be had you done those steps. So this is what the equation the calculator would give you. If you really feel strongly about doing this problem, let me know in class tomorrow and I will find the table for you. And you can do it on your own. Okay, so that's the equation you would get from the calculator. Now, the part B says the frequency of a musical note or wave is measured in cycles per second, or hertz. Okay, the frequency is the reciprocal of the period of the wave, which is measured in seconds per cycle. Estimate the frequency of the note produced by the tuning fork. Okay, so what we want to do here, we need to find the frequency, or I'm sorry, the period of this in order to find the frequency. So we're going to use this number here. It's sine So you're going to have 2 pi. So 2 pi divided by 2488.6. Okay, so this is the period, which means the frequency would be the reciprocal of it. Okay, so if you plug this into a calculator, you would get approximately 396
I already found your
hertz.
thing. I'm finding G-Star's thing now. Google it while you're here for a second.
All right. Okay, now over here, same thing. There is no table. It says a musical note like that produced with a tuning fork or pitch meter is a pressure wave. The table below, that's not there, gives frequencies in hertz of musical notes on the tempered scale. The pressure versus time tuning fork data in the table were collected using a CBL and a microphone. And for some reason I didn't type the question either. It's basically the same question. They want the equation and then they want the frequency. So I'll just give you the equation since you don't have the table. The equation is, let's see here, y equals 1.543
USB drive.
sine
This is what you want, one of these. These go
2468
wireless N adapter, wireless N adapter, wireless N, any of these.
635
$10. Take this
x
guide and plug that right into it.
minus 0.494 plus 0.438. Okay, so that's the equation. You would use the same steps as those other couple problems that we did with tables. You would make a scatter plot, find a best fit line, etc. So go ahead and pause here, see if you can figure out the frequency.